Good afternoon. So let us start chemistry part. This is April 3rd, JEE Main. So which are the following postulates of Bohr's model of hydrogen atom not in agreement? Is not in agreement with the quantum mechanical model of an atom. So, which postulate is not coincidence with the quantum mechanics? Atom is stationary, in a stationary state, does not emit electromagnetic radiation as long as it stays in the same state. Correct one, because stationary state means energy remain constant. An atom can take only certain distinct energies, E1, E2, E3 and so on. That means 1E1, 2E2, 2E3 are also taken as statements nothing but H nu or 2H nu or 3H nu. 1E1, E2, E3. These allowed states of constant energy are called stationary states of an atom. That means first level, second level, third level energy. No fractional values. Also correct one. Or you can take these states like this also. E1 first level, E2 second level, no fractional values. Electron makes a transition from high energy transition state, stationary state to a low energy stationary state, then it emits photon of energy. Correct one. E2 minus E1 equal to H nu. E2 minus E1 equal to H nu. Correct one. Electron in hydrogen atom stationary state moves in a circle around the nucleus. That means, the last point, Bohr's postulate is given as like this. Electron is revolving in a closed circular fixed path. Closed circular fixed path. That is Bohr's postulate, but this is not correct because Heisenberg said, de Broglie said, and also finally Schrödinger confirmed that electron has a dual nature. It is revolving around the nucleus in a form of wave nature. That is why it is impossible to find out exact position and exact velocity of electron simultaneously, not possible. There is a chance that is called probability present. Wherever probability is maximum present, that region is called orbital. Orbital. So that means circular line not correct. A region, that is called a region. A region. Spherical only. A region where the probability of finding the electron is more is called orbital. So, orbit given by the Bohr's model is not correct one, it is orbital correct one. Okay. So, this is not accepted by quantum mechanics. A spherical region around the nucleus where there is a maximum probability to find out the position of electron is called orbital, not fixed path. Okay. So, answer 4 is not an agreement. Next one, two statement given. First one, NN single bond is weaker and longer than PP single bond. Normally bond length increase, bond energy decrease, but some exception present is the exceptions. So, normally bond length increasing, bond energy decreasing or bond strength decrease is accepted reason, but it is not correct one. Nitrogen is single bond has 4 non-bonding electrons. Distance less, so strong inter-electronic repulsion present. Inter-electron repulsion. That is why this bond is ready to break. But phosphorus atomic size more, gap more, electrons same number only, 4 electrons here also. But distance is more between the two non-bonding pairs. Distance is more, repulsions are less. That is the reason N single bond, N is weak bond, P single bond, P strong bond. Therefore, nitrogen forms a triple bond because of sideways overlapping of p orbitals into triple bond, N triple bond N. But it is not possible because size more. Therefore, sideways overlapping is not possible. Or pi bond possible, not possible. Or pp pi bond not possible in case of phosphorus to phosphorus. So, but to single bond energy sigma bond compare, pp sigma bond is strong bond. Means don't take the same concept of general concept of atomic size increasing, bond length increasing, bond strength decreases. If you follow that concept, then NN bond is strong bond compared to PP bond, but PP bond strong bond than NN bond because of very small distance between the nitrogen. So, strong inter-electron repulsion present. That is why single bond, weak bond correct, but it is not longer, it is very short, very small distance. That is why shorter than PP single bond. That is why first statement false. Compounds of 15th group plus 3 state readily undergoes disproportion. Is statement given general form, but this type statements connected textbook in clearly given p block elements, nitrogen gives more oxidation states from nearly plus 3, minus 3 to plus 4 given, I think. But phosphorus gives plus 3 state, minus 3 to 1 minute. Because I check that values, because reference value is given textbook. Secondary p block elements. Yes, nitrogen from plus 1 to plus 4 undergoes disproportion. Plus 1 to plus 4, nitrogen. Nitrogen plus 1 to plus 4 undergoes disproportion. Okay. Phosphorus from value not given, only intermediate. Intermediate oxidation state disproportionate into minus 3 and plus 5. This is defined minus plus 5. This is just disproportion. Plus 1 to plus 4 values disproportionate. But remaining compound no disproportionation. That is important. But the compounds of 15 is general compound, general concept. General concept wise not correct one because compounds of 15 means meaning is all of them, but all of them not possible. Now, arsenic, antimony, bismuth do not show disproportion. Do not show disproportion. That's why it is for nitrogen okay, phosphorus okay, but not for all compounds. That's why this statement is correct one, not correct one. So, both are false. Option 2. Okay. 53. Given below two statements. So, statement 1, a catalyst cannot alter equilibrium constant of reaction. Correct one. Kpkc depends upon the only temperature and stoichiometry. So, 1 is correct. Statement 2, homogeneous catalyst can change the equilibrium composition of system. Temperature remain constant. Also correct one. Because homogeneous catalyst means take part of the reaction to form intermediates. Homogeneous catalysis means, for example, 2SO2 plus O2, 2SO3, NO is catalyst. Gas, gas, gas. Same phase of reactants and catalyst is called homogeneous catalysis. Products anything, but we want mainly reactants and catalyst only. Same phase is called homogeneous catalysis. So, what is change of composition means? Without catalyst 2SO2, O2, 2SO, very slow reaction. But now new compound formation takes place. SO2 NO plus O2 means catalyst take part in the reaction. This is catalyst. Take part in the reaction to form NO2. That is called a new intermediate. A new intermediate. That is called change of composition. This new intermediate react with second reactant 2NO2 plus 2SO2 combined to form 2SO3 plus liberation of same amount of catalyst. That is why catalyst definition is called substance which do not take part in the reaction is wrong. Which take part in the reaction. Example is one. Homogeneous take part in the reaction. But definition is called without consuming. Substance without consuming means amount remain constant. Taken is suppose 0.2 grams. Same 0.2 grams remain constant. But to take part in the reaction to form intermediates. Then net reaction is cancel NO, NO2, therefore 2SO2 plus O2 is equal to 2SO3. Okay, that's why composition changes. So both are correct. Both statements are true. One false, both 1 and 2 true. Option 2. Okay. Next, 54. Metal ions that have calculated spin only magnetic moment of 4.9 bm. 4.9 bm. Mu is equal to root of n into n plus 2. 4 into nearly 5. 4 into 4 plus 2. Root 24. Nearly 4.9. Means 4 unpaired electron requirement. Cr plus 2. 3d4. Fe plus 2. 3d6. 3d5. 3d7. 3d4 plus 3. 2s 1d. So d4 4, d6 4, d5 5, d7 3, d4 4. So 4 unpaired electrons are A, B, E. Option 4. Next, A plus B gives us C initial concentration of A and B relation as A0 equal to 8B0. A0 equal to 8B0. Half-lives of A and B are 10 minutes and 40 minutes. 10 minute to 40 minute respectively. If they start to disappear at the same time, both following first order kinetics, after how much will the concentration of both reactant, how much time concentration reactant both them become same. So after what time period they become equal concentrations. So look here, first A is equal to 8 B0. A is equal to 8 B0 initial value. It becomes a half A0 by 2. 8 by 2. Half life period 10 minutes. 10 minutes. That means in terms of B, B0 by 4. Sorry, 4B0. It is called 4B0 because by 2. Next half A0 by 4 means by 2 means 2B0. 10 minutes. Next half A0 by 8. B0. Next half A0 by 16. Then B0 by 2. B0 by 2. That means After 40 minutes, 1, 2, 3, 40 minutes, A becomes A by 16. A by 16 is nothing but B0 by 2. Okay. Now come to B. B0. What is B0 value? A0 by 8. A0 by 8. B0 value A0 by 8. 1 half-life. 40 minutes. B0 by 2. Half is equal to A0 by 16. That means for A0 by 16, A0 by 16 both are having equal concentrations. A0 by 16 also called B0 by 2 for this one. This are same, A0 by 16 also called B0 by 2. Both are having same amount of final concentration after 40 minutes, or in terms of half-life periods, A is by taking 4 half-lives, B only taking 1 half-life. Time period wise 40 minutes wise. Time period wise 40 minutes. So, this method simple only without using any formula. You can use formula also. I will take second method. Second method is A at time t is equal to B at time t. But we have first order formula A0 e raised to minus kt. B0 e raised minus kt. Exponential form of the first order equation. Okay. So, A0 is equal to e raised to minus, or substitute the value in terms of B0, it is 8B0 minus, I will take KB, Ka. B0 cancel. So, 8 is equal to, taken that side, plus E0 Kat minus Kbt. Take logarithm on both sides. Ln 8 is equal to Ka t minus Kbt, or t common Ka formula, because t half is equal to 0.693 by K, or ln2 by K. Okay. So, ln2 by t half A, t half 10 minus ln2 by t half of the B 40. Take ln2 common. So, ln 8 is equal to t into ln2 1 by 10 minus 1 by 40. T is equal to 40. Okay, but it is a long method. When fraction is not suitable, suppose question amount is suppose 1 by 15, 1 by 14 means not possible, because 1 by 2, 1 by 4, 1 by 8, 1 by 16. When fraction not possible, then go to equation method. This is equation method. Okay. 56th one, correct the structure of L-fructose. So, a small confusion about L-fructose and D-fructose. D and L nothing but object and mirror images for any compound. D and L are having object and mirror image relation. Nothing but enantiomers. But enantiomers use generally d small l. This is only configuration with respect to standard element, standard compound. So, D and L named as per standard substance or reference compound configuration or arrangement. Configuration also means arrangement. So, what is standard compound? In glyceraldehyde. So, it's called standard compound. This is CHO, CH2OH. This is called glyceraldehyde. So, in the glyceraldehyde, chiral carbon present 1, 2, 3. Last but one. So, last but one means second. OH right side is called capital D. Left side is called L. That's why don't take only this bond left side. Entire image is taken because one bond not will rotate, entire molecule rotate. That is taken as image. CHO, CH2OH, HOH. Last but one, chiral carbon, left side is called L form, L series or L form. So, it's called D series, not a D configuration, L series. Therefore, reference compound is having D and L, object image. The derivatives are same type. Derivatives, fructose, CH2OH, C double bond O. If first two difference only, remaining constant for glucose, fructose. CH2OH, CHOH, CHOH, hat trick, OH, 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 hat trick. Now reverse, OH. That is called D-fructose. How to confirm D-fructose? Same rule, last but one, chiral carbon, OH group on the right side, 1, 2, 3, 4, 5, 6, third chiral, fourth chiral, fifth chiral, which is last chiral? 5. So, also called last chiral, OH on right side is called D series. Okay. D-fructose. Now, what is L-fructose? Image. The plain only, you can write anywhere. OH, OH. Is called last but one. 1, 2, 3, 4, 5, last chiral. Left side is called L series. Therefore, the name is called L-fructose. L-fructose. Okay. So, what question given now? Correct structure of L-fructose. So, only chiral can take. You can take, this is not chiral, you can write anywhere. This is CH2, that's this side, no problem. Only chiral is important. So, this also. We want numbering side taken 1, 2, 3, 4, 5, 6. If 5, 6 OH, left side. CH2OH 1, 2, 3, 4, 5, 6. So, option 3 is not correct because we have 2 OH on the left side. This is not correct. This is correct. But to verify this one, this is not correct now because the alternate present, one light, one right. So, not we want 4, 5 both the right side. Option 3 only correct. Is CH2H CO can write anywhere because they are not chirals. Can write like this, like this. These 3 important, that is 3, 4, 5. Object image relation of enantiomeric centers. Okay. A, B, C, D correct statements. The last one missing. What is that one? NH2, NH. Here NH. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 on 3 on metamers. Because one small doubt here, metamers, position isomers both are identical, but metamers are special type of position isomers. All positions not metamers. Metamers are one type of position isomers. So, metamers are one type of position isomers, but when question given as metamers given statement to follow metamers only. If metamers not there, then go to the position isomers. That is why metamers correct statement because of difference of alkyl group on either side, because this side ethyls, but here methyl propyls. Next, CN-NC functional isomers. 1, 2, 3, 4. 1, 2, 3, 4. Same. So, formula same present. Cyanide, isocyanide, functional isomers, correct. Next, position isomers. First check the formula. 1, 2, 3, 4. 1, 2, 3, 4, 5. Not same formula because 1, 2, 3, 4, 4C. 1, 2, 3, 4, 5, 5C. Therefore, not correct. Formula different. Next, first check the formula, then go to statement. 1, 2, 3, 4. 1, 2, 3, 4, 5. Homologs given, not functional. Homologs means difference of CH2. 4 plus 1, 5. But it must belongs to same series only. Homologous primary or homologous secondary. But one compound is primary, one compound is secondary. Compound formula is different one, not isomers, but not homologs. Because homolog for this compound, butylamine, pentylamine. This secondary amine, again same secondary amine equivalent, but not between the two different types of amines. Two different amines forms functional isomers only if the formula is same. If formula different, they are different compounds only, different type of amines only. That is why D also not correct one. That is why A and B are correct. So, D compound, they are not isomers, they are not homologs. They are just only two different types of amines. Next, 59, 10 raised to minus 9 grams each of the following elements. Highest number of atoms. So, this question lo no atomic number, no atomic mass. Just imagine approximate atomic numbers or at least place. Polonium belongs to 16th group, last element. Oxygen, sulfur, selenium, tellurium, polonium. 16th group. Last means 116. Last element. Minus 32. 84. 84 plus 32. 106. So, polonium 84. At least nearest atomic number. Praseodymium, lanthanide, lanthanum, cerium, 56, 57, 58. Lanthanum 50. Sir, 1 minute. Scandium, yttrium, lanthanum. 21 plus 18. 39 plus 18, 57. Now here cerium, praseodymium 58, 59, 59, lead 82, carbon group, platinum 78, nickel group. So, atomic mass nearly more than double. So, low atomic mass for the praseodymium, because atoms equal to moles into Na, moles equal to mass by atomic mass. Atomic mass is high for same mass, because same mass given. So, W constant, then relation only depend on the atomic mass. So, same W, atomic mass high means atoms less, atoms low means atoms high. So, low atomic mass praseodymium 59 atomic number, so contains low atomic mass, less means atoms are more. So, answer praseodymium only. Next, correct statement. Process of the addition of electron to a neutral gaseous atom is always exothermic reaction. Process of addition of electron to a neutral gaseous atom is always exothermic reaction. That is atom plus electron is equal to A minus. That is electron gain enthalpy. But the statement is given, always given. Exothermic, okay. Generally, always means everyone. But to noble gases not exo. Nitrogen, beryllium and magnesium are endo. So, delta H Eg is positive, also present for inert gases, nitrogen, beryllium, magnesium. That's why always not correct. Removal of electron from isolated gas atom is always endo. It is correct. Ionization enthalpy always endo. No exception. First ionization energy of boron less than that of beryllium. Correct one. Because beryllium fully filled s orbital. Electronegativity of carbon 2.5 in both of them. No, because when compound is given, depend on the surrounding atoms. If compound not given, element taken as 2.5 correct. Compound is Cl4, CH4. Cl4 is more electronegative group compared to H4. That's why CCl4 as a compound is more electronegative than CH4. So, not correct. Lithium most electropositive. No. Cesium. Down the group electropositive increases. Only B and C correct. Down the group electropositive increases. Cesium. Okay. Option B and C correct. 1. 60. Which of the following properties will change when system containing solution 1 will become solution 2? That means initial to final. Initial is 10 mole solute, 10 liter water. Final is 1 liter solution, solution 1, 1 mole of solute X, 1 liter water. That means depends on the quantity or not depend on quantity. Molar heat capacity, density, concentrations. These 3 properties are one type. This last one type. These 3 properties are intensive. Do not depend on quantity. Intensive properties. This property extensive. Changes. Because depend on the quantity or amount. 10 moles of X, 10 liter of water, solution 1, but it contains solution 1 only 1 liter. That means amount changes. Amount changes means Gibbs energy changes. But density remains same, molarity remains same, molar heat capacity remains same, because concentration means moles per liter, molarity. For example, you can take, this is called 10 molar sugar. So, from this vessel, you can take 10 ml outside, molarity 10 only. You can take 20 ml outside, molarity 10 only. That is why molar concentration is taken as a intensive property. Okay. So, these three properties do not depend upon the quantity or amount, but Gibbs energy change. Question given is changes, Gibbs energy changes. Option 4. Next 61. Number of molecules below which cannot give iodoform test. All alcohols and ketones. Alcohols lo methyl carbinol. Methyl carbinol. CH3 CHOH X. This is essential. X equal to hydrogen, alkyl, phenyl, vinyl, allyl. X equal to hydrogen, alkyl, phenyl, vinyl, allyl. All these ketones are carbonyl compounds. Methyl keto, CH3, CO, X. X same only. That is essential part in both cases. But X not equal to OH, chlorine or halogen, means lone pairs or NH2, because the lone pairs will give resonance stability in the CH3CO compound, because first step oxidation, this one oxidation into this step, first step mechanism. Next converting into iodoform or haloform. So, first alcohol converted to aldehyde ketone, but X gives lone pair resonance stability for C double bond O. That is why X not equal lone pairs. You can take pi bond, no problem. Vinyl, allyl, except lone pairs. Ethanol, correct? Isopropyl alcohol, correct? Bromoacetone, correct? Because CH3, CO, CH2Br. Already one bromine is there. Second bromine is CHBr2. Third CBr3. Next bromoform. So, this is nothing but iodoform or bromoform possible. 2-butanol, correct. 2-butanone, correct. Butanol, not correct, because CH3, CH2, CH2, CH4, methyl keto absent. Pentane 2-on, 2-on correct. Pentane 3-on not correct, because 3-on, 2 side ethyl present. Pentanol, not correct. 3-pentanol, not correct, because 3-pentanol, 1, 2, 3, 4, 5, not having methyl carbinol. So, how many not correct? 1, 2, 3, 4, 4 compound not correct. Iodoform test also called taken as haloform test only. That's why don't take strictly iodoform. This is actually bromoform because next step lo CHBr2, next CBr3, last conductivity CHBr3. Bromoform. Commonly given as iodoform test. Okay. So answer 2. Next, A, B, C respectively in the following sequence. A into diazonium salt, diazotization. Diazotization means primary aromatic amine, nothing but aniline. So A is equal to aniline. Aniline. Next to B, Ki, iodobenzene. Sandmeyer reaction. No, Ki no reaction, no name, just only I. For chloride, bromide, Sandmeyer reaction. Chloride, bromide. Iodide no reaction, no name, just only iodobenzene. B. Next to C, Fittig reaction. Two aryls. Diphenyl. So A, B, C respectively. A aniline, B iodobenzene and C diphenyl. Option 3. So next 63. In the following reactions, which one is not correct? So wrong answer. Diazonium chloride ETOH, OET. OET not correct because benzene diazonium chloride plus C2H5OH gives benzene plus CH3CHO plus HCl. Alcohol acts as a reducing agent. So it should be benzene answer. Not correct. H3PO2 correct. Benzene, because there are two methods for benzene. One is using ethanol, one using H3PO2. In this one, byproduct equal to H3PO3 byproduct plus HCl. So it's correct only. Potassium is correct, iodobenzene. This is correct, cyanobenzene. So 2, 3, 4 correct. Only first one wrong. ETOH gives benzene. Next, correct order of complexes. A, 5, 1, 6 ammonia, cyanide. What is question given? Wavelength of light absorbing. Ligand strength proportional to delta or energy inverse to wavelength. Splitting energy or energy inverse to wavelength. So ligand strength inverse to wavelength. First option compound A, 5 ammonia, 6 ammonia. 6 ammonia strong field ligand effect, delta more. Cyanide very strong ligand. Okay. So strongest ligand is cyanide and weak ammonia weak. Okay. But question lo this is plus 2 state given, plus 3. The delta value again depend upon the oxidation state or effect nuclear charge of metal or oxidation state of metal. So that means if plus 2 state low, splitting less oxidation number, less delta. Delta less means low strength. Delta less means lambda high. That's why D is having high lambda, low E and low delta because of plus 2 state. Next all plus 3 only given. Plus 3, plus 3, plus 3. We know cyanide last place only because strong ligand, highest energy, high energy, lowest wavelength. Next, so A and B. A, B, water, here no water, water weak ligand. So, weak ligand low energy, that is A. This is completely ammonia. B. D, A, B, C. C is having low wavelength, high energy and high amount of splitting energy. So, option 1. Okay. Next 65. PCl5 gives PCl3 plus Cl2 equilibrium. Addition of xenon means noble gas or inert gas. There are 3 conditions, inert gas conditions. First condition apply. Addition of inert gas at constant pressure with delta N not equal to 0 favors a direction where volume or number of moles increase. Volume or number of moles increase. There is only one condition, remaining always no effect. Addition of inert gas at constant pressure with the delta not equal to 0 means number of products and reactants not in same moles, different moles. Favors a direction where volume or number of moles increase. So, delta not equal to 0 because 2 moles and 1 mole. Delta N is 2 minus 1, 1 means not equal to 0. Then pressure remain constant, which pressure remain constant. So, correct one. Then favor a direction where volume or number of moles increase. 2 moles, 1 mole. So, forward is called moles increase or volume increase. Favorable. Addition of inert gas favorable in the forward direction. That means PCl3 and Cl2 will increase. PCl5 increase, wrong, because favor forward direction, decrease. Cl decrease, wrong. All remain constant, wrong. PCl3 increase, option 4. Next, 2 moles ethylene glycol, each ethylene glycol and glucose dissolved in 5 grams water. Boiling point of resulting solution is, but both of them I factor 1 because no dissociation, I factor 1. So, direct formula delta TB equal to Kb into molality, Kb 0.52, number of moles, both glycol and glucose. By mass of solid in kilograms. So, 0.52 moles are 2 plus 2 by 0.5 kg. 4 into 8. 0.52 into 8. 4.16. So, 100 plus 4.16, 104.16 Kelvin, Celsius, Kelvin 273, 277.16. 2 moles each of them, 2 plus 2, 4 moles, so 4 into 2, 8, 8 into 2, 16, 18.5, 8 into 5, 40 plus 1, 41, 416, correct? So I think conversion value not given here. You can take correct value 273.16. Then 273.32. Actually 15. Then 31. Because you're not given conversion. 273.15 is correct factor. Next, 3-methyl 6-oxoheptanol. 1, 2, 3, 4, 5, 6, 7. Heptanol. 3-methyl 6-oxoheptanol. First aldehyde, all. Because aldehyde termination group number 1. Then both addition with removal of oxygen, intramolecular. That means first to 6 join together. 1, 6 combine. Take constant number 1, 2, 3, 4, 5, 6. 1, 6 joined by double bond. Next, fill up branches. 6th has one branch, 7. 5 no branch, 4 no branch, 3 has a branch, 2 no branch. So this compound, that means methyl's opposite and connected to double bond. Methyl's opposite to connect double bond. Option 2. Next, PF5. PF5, PCl5 both same only, sp3d. SF6, sp3d2. NiCO strong ligand, sp3. PTCl4, dsp2. Because for platinum plus 2, palladium plus 2 and so on for 4D and 5D series, other metals also with the coordination number 4, are always dsp2 square planar complexes irrespective of ligands. Irrespective of ligands means any ligand it is fixed, but general plus 2 or plus 1, ruthenium plus 1 sometimes. So plus 2 or plus 1 states of the metals with the coordination number 4 present independent of ligands, any ligand dsp2 for 4D and 5D series only. NiCO4 we know because pairing takes place to become sp3 hybridization. Okay. So 2, 3, 4, 1. 2, 3, 4, 1. Option 1. Next, least acidic compound is the following. So this is just order of strength only. Generally, mineral acids like HClO4 strong acids, sulfuric, nitric, HI, HBr, HL, very strong acids. Then sulfonic, then carboxylic, then carbonic acid, then HCN, then phenol, then water, alcohol, alkyne, ammonia, hydrogen, alkene, alkane is called common order of acidic property of compounds. Picric acid, very strong acid, more than this two also, very strong acid. So here not required. This is phenol, sulfonic, carboxylic, alkyne. So order is taken as B more than, C more than, A more than, D. So not order, only least, last D is least. compound alkyne. Next, limiting molar conductivity for cations in the water is H plus ion contains highest limiting molar conductivity. Then all other cations, no exception, H plus highest. Okay. Next, size and charge. First go to charge, important. Next go to size. Charge is high, conductivity is high. Calcium 2, magnesium 2. So both 2 to present. Then depend on the hydration. Calcium plus 2, less hydration. Mobility increases. Magnesium more hydration. Next, potassium, same reason. Size more, less hydration, more mobility. So first go to charge. Charge is more, molar conductivity is also more. Next go to the size. Okay. So H plus, calcium, magnesium, potassium, sodium. Size inverse to hydration. Okay. Next, during estimation of nitrogen by Dumas method, 0.40 grams X gives dash ml of nitrogen at STP condition. First to check the molar mass, C4 48, 2, 4, 8, 10, 10H, 10, 2 nitrogens, 28, 86 grams. Okay. That means C4 H10 N2 CX HY NZ plus X plus Y by 2 copper oxide is equal to X carbon dioxide plus Y by 2 water plus Z by 2 nitrogen plus X plus Y by 2 copper. Z value 2, 2 by 2, 1 mole. So 1 mole of the compound gives 1 mole. 1 mole mass value 86 grams. Volume, ml volume 22,400 volume. Then given mass how much? 0.42 grams. Therefore 0.42 grams gives 22,400 by 86 into 0.42. 109.39. Okay. This method is Dumas method. Next to 0.5 grams of compound combustion gives 1.46 grams carbon dioxide, 0.8 grams water. Percentage of carbon in the compound is. Direct formula apply. Percentage of carbon equal to 12 by 44. Mass of carbon dioxide by mass of compound into 100. 12 by 44 carbon dioxide is 1.46 by compound 0.9 into 100. Just one step only. So 146 into 12 by 44 by 0.9, 44.24. So 0.5 grams, not 0.9. Mass of compound 0.5 grams. 79.6. Okay. Next, number of optical isomers exhibited by the complex A, iron complex. Fe3 plus state oxalate, ferric oxalate complex. FeC2O4 taken thrice, -3. Ferric oxalate complex. Ferric oxalate complex lo M A thrice because symmetric ligand. That is AA. So, all A only gives only optical isomerism. Dextro and levo due to absence of plane of symmetry. Due to absence of plane of symmetry. Absence of plane of symmetry. No geometrical isomerism because all atoms are A, are same. That is why 2 dextro and levo, D and L. That means if it is structure wise, central atom is, I will take metal M, Fe plus 3 and oxalate formula COO minus, chelation ligand. Take O minus to O minus. CO bonds constant. Same other side. And also here. So, this compound not having plane of symmetry. Not only here, any AA type compound no plane of symmetry, optically active, which is giving its object and image. Dextro and levo. Next, sublimation value CH bond HH CW1C, formation of ethylene find out. So, apply formula directly. Delta H naught F bond energy of reactants minus bond energy of products. Reactants are equation first C2H2. 2 carbons solid plus 2H2 gas into CH2 double bond CH2 is called a reaction. But solid cannot take part direct reaction. Solid convert first gaseous state, then reaction takes place. Solid to first 2 moles of gas conversion takes place. Our step name sublimation. I will take plus S. E step dissociation. So, right here reactant energy means carbon sublimation energy, carbon solid to carbon gas. How many moles? 2 moles plus 2 moles H2 bond energy. Other reactants minus products 4 CH bonds and 1 double bond C products. Delta HF nu find out. Sublimation value 710. 2 into 710 plus 2 into H2 bond energy 436 minus 4 into CH bond energy 414 plus double bond C energy 611 that is solving is 25 kilojoules per mole. Okay. So, this step from sublimation of carbon solid to carbon gas. Next 75, A plus NaCl sulfuric acid gives chromyl chloride. So, A is equal to potassium dichromate K2Cr2O7. Its test name is called chromyl chloride test. In practical chemistry also present and D block also chromyl chloride test for Cl minus ion conformation test. Chromyl chloride vapor with B, NaOH, sodium chromate, Na2CrO4, yellow solution, not PPT. Solution chromate, acidic medium comes to dichromate. CrO4 2 minus in acidic medium into dichromate. Cr2O7 2 minus. This interconvertible dichromate again backward reaction into chromate basic medium. That is the reason dichromate only working as oxidizing agent in the acidic medium, not in the basic medium, because no dichromate availability in the basic medium, because conversion into chromates. Correct 7 maintain, both 50-50 present, 50% chromate, 50% dichromate. That is why dichromate is always working as oxidizing agent in the acidic medium only. So, that is compound C. AC both same only. Number of terminal oxygen present in the compound C. So, A and C both same only, dichromate only. Dichromate structure equal to one bridge bond, remaining are double bond O and single bond O minus. E part resonance, therefore, resonance structure is given like this, having equal bond length, but bridge bond no resonance. That means partial double bonds at terminal sites. That is called resonance hybrid of the dichromate. Number of terminal oxygen atom the compound C, 3 plus 3 6. Okay, so this center bridge atom option answer interior question 6 answer. Okay, thank you.